All right, so we're going to kick off this next session. I'd like to introduce you to Dr. Sarbari Gupta. She's the CEO and founder of Electrosoft. She's going to be talking to you about leveraging Passkeys for federated federal government environment.
Okay. Oh, that's true. Okay. Lots of people have commented how bright the light is, but that's true. So we have a small group here, but how many of you were here for the last session? I guess just by a show of hands. Okay. So it's kind of a follow-up to that, you know. So I'm really happy to be here to be sharing with you some thoughts on how to leverage Passkeys for a heavily regulated environment, the federal government environment. And so at the end of the session, you should be able to walk away with several models for how to use Passkeys. Oh, that's true. I do need that. Thank you. Several models for how to use Passkeys, you know, for the government. So let's see. Okay, well, agenda. Let me just speed through it. There's a lot of slides, and these sessions are only 20, 25 minutes. I'm used to the 40-minute type of session length, you know, at other conferences, but we talked at length about PIV cards in the last session, right? So I don't know if I need to repeat some of the things that are on this slide, but the PIV card is not just the form factor that holds the PIV credentials, you know, the PKI certificates, but it's also the bigger life cycle around the PIV card that's really important, you know, the strong identity proofing and vetting and suitability checks that, you know, the panelists spoke about at the last session, as well as the life cycle management, you know, that goes with the PIV card and all of the credentials that it holds. And so, you know, in terms of the strengths of the PIV card, of course, it's the rigorous identity proofing and vetting that complements the strong form factor, you know, the fact that it's a smart card with an IC on it, and that's where all the, like the goodies are stored, I guess. And also, as I said, the strong life cycle management processes related to PIV cards. But the drawbacks of the PIV card are also many. In fact, you know, I had the good fortune to work with the NIST team back in 2004 when they were writing the FIPS 201 standard, the standard behind the PIV card. And back then, smart cards were the latest and greatest technology, and so that's what they sort of, you know, embraced to respond to HSPD 12, the directive that came out back then. But at this stage in 2023, you know, smart card seems like a passé technology. However, and so, you know, things like it requires a smart card reader, you know. So many of the computing platforms that we use these days, they're mobile. They don't support, you know, smart card readers, et cetera. So that's a pain. And also with a PIV card, you've got to carry the PIV card with you, right? And if you forget it at home, now you have a problem authenticating to your systems. Derived PIV credentials. So what are these? I think, again, those of you who were here for the last session, you may have heard some references to SP 800-157, which is the NIST standard, or the guideline, actually, for derived PIV credentials. The last one that was written, 800-157, came out in 2014. And again, I was fortunate to be able to be a part of that team helping to write that standard. But back then, derived credentials could only be PKI based. You know, there was no option for any other type of credential. But with the release of the Rev 1 last year, now it's been opened up to allow non-PKI derived credentials, and that's where, you know, FIDO2 and Passkeys come in very, very conveniently. And so the lower part of this slide, I guess, non-PKI derived credentials. So all derived credentials. So derived, what is the word derived? Why does it, you know, why is it part of the phrase? So obviously the PIV card represents a very strong lifecycle managed, identity vetted, you know, strong credential, right? And so the thought is to use that as an anchor authenticator to then issue additional authenticators that can now, you know, leverage the other processes around the PIV card, right? So for non-PKI derived credentials, first of all, any derived credentials, they can only be issued by the agency that issued the PIV card in the first place. So if I'm working at the Department of, let's say, Education, I'm a contractor, let's say there, so I get a PIV card issued by the Department of Education. And so if I have to get a derived PIV credential, only the education department can issue that to me. And for non-PKI credentials, you know, only the issuer, pretty much identity provider, is the one that can validate the credential as well, because it doesn't have the third-party trust fabric that a PKI credential has. A couple of other requirements from 800.157 Rev 1 is that in order to issue a derived PIV credential, at the time of issuance, there is supposed to be a check to make sure that the user's PIV account is still active. Now, what does that mean? You can have a valid PIV card, but it's possible in certain scenarios that perhaps the PIV account has been deactivated for some, security reasons or whatever. And so it's important to check at the time of issuance that the PIV account is active, but it's also necessary to check at each use of the derived PIV credential whether the PIV account is also active. And finally, another requirement, for credential management purposes is that, all derived credentials that are issued against a PIV card have to somehow be associated or linked with that PIV account. And the reason being that, at the time that the PIV account is, let's say, deactivated or terminated, all of the related derived credentials could also be terminated at the same time. You don't want them to be usable beyond the PIV account, right? So anyway, so those are some of the key requirements. And so this diagram here essentially shows, well, I didn't mention that, with this these sets of constraints that I just mentioned, it pretty much boils down to the use of federation in order for relying parties to actually use non-PKI derived credentials. And why that is because, as you can see in this picture, step one is where, let's say the user at the bottom has a derived PIV passkey, a DPP, that I kind of mentioned earlier. And so they use it to authenticate to the identity provider. Identity provider checks the agency identity management system or repository to make sure the PIV account is active. And at that time, they can issue an assertion, a federation assertion, using, let's say, SAML or OpenID Connect to the relying party. And then the relying party has to validate that assertion and then provide services to the user. And in such a model with federation occurring, there is a requirement in general to have a federation trust agreement between the IDP, the identity provider, and the relying party. The reason being that, even at a technical level, the relying party has to be able to validate the signature on the federation assertions, right? So they need to have that trust root or the trust, the signing key. But even otherwise, policy-wise, is this a trustworthy identity provider or not? Those kinds of things have to be, based on a trust agreement. So I want you to remember this diagram because I'm going to be showing you a bunch of diagrams like this that are very similar with minor differences because I'm going to share a few solution models, for how to do these things. So anyway, passkey, this slide, all of you know what a passkey is, and at a FIDO conference, I don't have to talk about passkeys again, but I wanted to mention that the strength of the passkey that we're going to be talking about further is really the fact that it's based on asymmetric key cryptography. It's a multi-factor authenticator. It's activated by a biometric or PIN, phishing resistant, et cetera. But we all have heard multiple sessions, we talked about how FIDO is great in many ways, but it doesn't address, what happens before the FIDO credential gets issued. And it doesn't really have anything good to, good coverage for how to manage those credentials over their life cycle. And so derived PIV passkeys, so DPPs, so that's a new term, let's say. But what are these? So essentially, DPPs are PIV-derived credentials that happen to be passkeys. So hence DPP name. And we already covered many of the requirements from 800.157. So let's jump into some solution models or architectures for implementing derived PIV passkeys. So model number one is the easiest one. This is where the agency itself decides, I'm going to be the leader in the space. I'm going to issue DPPs for all of my PIV card holders. And so in this case, the agency takes on the burden of implementing and operating, maintaining, managing the whole passkey infrastructure. So anyway, the other things. Let me move on quickly because we do have a short session here. So the model number one in pictures, this is the issuance step, let's say. So the user comes in with a PIV card. Step number one, they authenticate using their PIV card to prove that they can control and own it. So the identity provider, which in this case happens to be implemented or instantiated by the agency itself, agency X in this example. So it does, validation of the PIV card, then it checks the agency identity management system to make sure that the PIV account is still active. If so, then it goes ahead and causes the passkey to be generated, on the user's whatever platform or device they're using. Private key stays with the user, public key goes up to the identity provider. And based on the requirements I said earlier, I talked about earlier, the public key of the new DPP, the derived passkey, also has to be associated with the user's PIV account, right? So that's, you see the dashed arrow from right to left. So that's actually within the agency some sort of an interface for the identity provider, the passkey provider, to then make the queries and associate the resulting passkey with the user's PIV account. So post-issuance, here's the next scenario, which is how do you use the DPP now that it's been issued? And so to use it, of course, the user has the private key of the passkey, local to them. They use it to authenticate to the identity provider. Identity provider, again, has to check the status of the PIV account. They can't just, it's not enough to just validate the passkey per 800.157 Rep 1. So if that all goes well, then the identity provider sends a federation to the relying party within the agency itself, and it all works out. So given this model, what are some of the benefits and drawbacks? So the benefits are that it's simple. It's all controlled by the agency itself. They have full control over the full implementation. And so because of that, this internal interface to talk to the IDMS, let's say, might be a little easier because it's all within the family in a sense, right? But some of the drawbacks are that the agency has to deal with this more complex passkey implementation, manage it, etc. So those are, and I guess I didn't mention another benefit is that the federation trust agreements are pretty simple because it's all again within the family. It's the relying parties within the agency, identity provider managed by the agency. Okay, so now let's talk about model number 2, which is the initial outsourced model. So the agency decides, what, we don't want to go through all this hassle of issuing passkeys, verifying them and whatnot. We're just going to hand it to a vendor. And so in this case, they engage in a third-party vendor who's going to be the identity provider. And then let's look at what the pictures look like in this case. So this is for DPP issuance. So again, the same old story, PIV card is used by the user to prove that they have a valid PIV card. The orange identity provider here happens to be a commercial or third party, let's say. And so that identity provider now has to have a way to query the agency's IDMS, the identity management system, to ask, is this user's PIV account still active? Those interfaces don't really exist today, but just saying, for theoretical purposes, that's what needs to happen. And then for the actual authentication using the DPP, again, it's kind of the same story. The user has the DPP. They can authenticate using it, let's say over WebAuth 10 to authenticate to the identity provider, the orange block in the middle. But again, the identity provider has to check whether the user's PIV account is active. In fact, I forgot to mention, okay, in the last slide, there's one arrow, but actually steps 2 and 4 both need to interface with the IDMS, not only to check the status of the user's PIV account, but also to link the new passkey, the public key, to the user's account. Anyway, so that's kind of what happens. But in this model, you'll notice that the identity provider and the relying party are now in different organizations, right? Agency is the one who owns the relying parties. Identity provider is some outsourced public commercial company. So now there's a much greater need for a more substantial federation trust agreement, between the orange block, the identity provider, the commercial identity provider, and the all the relying parties within the agency. So the benefits of this model is that it's an outsourced model. Agency doesn't have to bother with the complexity of passkeys and maintaining them and whatnot. But the drawbacks are that, as I said, a much more substantial or difficult, complicated federation trust agreement needs to be developed. Special APIs need to be opened up to the IDMS, which is a huge problem because the IDMS, it holds very sensitive information about all of these users in the agency, right? So every agency employee, every contractor that works at that agency will have a record in the IDMS, and it has a lot of personally identifiable information. So, opening up an API, however simple it is, may not, it's very, it gives, probably keeps the agency people up at night. And then if we went forward with this model across the US federal government, we may come up on a scenario like this, a spaghetti scenario, where different agencies are hooking up with the different commercial identity providers. They create these unique or unique, I guess, non-standardized APIs to hook up to the IDMS. And so it's kind of a mess, right, as you can see. So then comes the final and the model number 3, I guess, which is called the Federal Trust Broker. So what happens here is that to kind of alleviate the spaghetti problem that I was illustrating in the last slide, you introduce an intermediary, a trusted intermediary called the Federal Trust Broker, which acts as a trusted intermediary, but also an agent that vets the commercial identity providers, to make sure that they are in compliance with certain requirements, they're trustworthy, et cetera. But when an agency decides to go along this path and sign up with the FTB, their setup process would be to say that, okay, which are the approved set of identity providers for the FTB? And the agency will select one of them, as its provider. And the other thing that the agency needs to do in this model, I'll show in the next couple of diagrams, is to agree to have a periodic push of data regarding the PIV account status within all the PIV cards within the agency. So what does that mean? So let's say it's a daily push. There's not a lot of information needed. It's almost like a list of, let's say the agency has 2,000 personnel that has PIV cards. So a list of 2,000 account names, and then whether it's an active or terminated or deactivated status. That's about it. And then the agency also establishes a Federation Trust Agreement with the FTB, as you can see in the pictures below. And this is a little easier because FTB is probably going to be a government operated entity. And so other agencies will find it easier to trust another government entity than a commercial provider. Okay, so this is the issuance picture again. All the same things happen. User validates, authenticates with their PIV card to the third-party vendor who's acting as the identity provider for DPPs. But in this case, that identity provider, instead of requiring a specialized API into the identity management system for the agency, they have an API that talks to the FTB instead. And I mentioned how the FTB is going to get a periodic data push. That's the step number 0 to the top left. Of PIV account summary data, right? So again, let's assume it's once per day. So the FTB has a local database that it knows which accounts are active and which are not active for all the agencies that have signed up with the FTB. So the step number 3, I guess. FTB checks its local data to make sure the account is active. If so, then the DPP is generated and whatnot. And the identity provider, step number 5, submits the new public key for the passkey issue, generated to the FTB instead of the IDMS and the model number 2. Okay, so now let's look at what happens post issuance of the DPP. So now the user has a DPP. It authenticates to the identity provider in orange. But this is a little different. So in this case, the identity provider, validates the DPP, and then it sends a assertion to the FTB. So before, if you recall, the identity provider was sending an assertion to the agency relying party, but instead in this model, it'll be sending the assertion to the FTB itself. FTB has a local view of which accounts are active. If it's an active account, then the FTB generates a second assertion and signs it. That's step number 5, and sends it to the agency X relying party. And life is good. User A gets the services it was requesting. So you'll see that there are 2 sets of assertions, right? But okay, so remember the spaghetti model I showed, or diagram I showed before? This is what happens when the FTB is in the middle of it. So all of these agencies supposedly have signed up to get passkey services through the FTB, and so they're doing all those dotted lines on the left side are basically the daily or whatever periodic push of PIV account status data to the FTB. And on the right side, you'll see a bunch of commercial identity providers, passkey providers, let's say. So they've signed up and they've been vetted by the FTB as being good enough for government service. And so all of those identity providers on the right side, they connect using a common API to the FTB. And as a result, some of the text on the bottom shows that instead of each agency kind of getting their hands dirty implementing passkeys and derived PIV passkeys, if it's done this way, agencies across the government, they'll save a lot of money and trouble by having this kind of a shared service through the FTB. And the other benefit of doing it this way for agencies is that agencies can now, they're not locked into a certain commercial identity provider. They can switch it out if they want. Now, they will lose all the passkeys, of course, issued by that provider. But on the other hand, at least from a business perspective, they're not locked in with a specific identity provider on the right side. Okay, so model 3, benefits, let's say. So the benefit is still that agency gets to outsource their DPP implementation and O&M. The vendors, IDPs, instead of having to deal with a dozen or so different federal agencies, they have only one entity to deal with, the FTB, and a single common API. Agencies also, instead of having to figure out, okay, which of these vendors is the best one or whatever, vet them, they establish a trust agreement, with that FTB entity because that's where the assertions are going to come from. But here, some of the considerations, are that this common API, it has to be developed and maintained over time, right? I mean, that's not a big deal, but that has to be done. But the other thing is, given that now there's more transactions happening, 2 sets of assertions, FTB is going to introduce a delay in the process unless it's it has to be highly scalable so that multiple agencies can sign up, but it also has to be very high performance. However the architecture is implemented to do that, to provide that the performance, I guess, goals. So that's kind of model 3, and So yeah, I guess I'm at my summary, derived PIV passkeys. So basically, it's a way to marry the strengths of the PIV card, and not just the card, the whole PIV process, and the strengths and lightweightedness of the passkeys or FIDO2 credentials in a really nice way, because it inherits all of the high assurance identity proofing from PIV and the lifecycle management from the PIV processes. It's a strong multi-factor credential, et cetera. And of course, the best part of DPPs or passkeys in general are the user friendliness, how easy it makes it for the end users, and the privacy preserving properties, of course, biometrics don't leave the local platform and such. But for agency users, what are the benefits? First of all, the agency users have a nice modern authenticator that they can use, which are easy to use, right? And because most of the modern platform operating systems and/or browsers support passkeys, and so rolling out DPPs may be easier than some other types of authenticators that might need special middleware or something like that. Also, help desk calls get reduced. I mean, everybody knows that the largest percentage of help desk calls are for forgotten passwords, right? So now you don't have to worry about that. So hopefully agencies reduce costs, due to reduction in help desk costs. And that's it. And now you've learned multiple models of implementation. And I don't know if anybody here is from an agency, but at least it gives you some food for thought on how to use passkeys in a slightly different, more complex, models where it's not the relying party who's going to be your passkey issuer. It's going to be another entity, and then you have to federate, to make sure that you have the level of trust for that authentication. So that's my talk, and I don't know if we have any questions.
Anybody in the room have questions?
Was there a question? No. Okay.
All right, so we're just about wrapping up here, so we're going to start a break now in the expo hall, and it runs till 4:30, so we'll see you back then. If you do have questions for Dr. Gupta, please.
Yeah, I am here until tomorrow, so if there are any questions, if you'd like to chat further, certainly I'd be happy to. Thank you. Thank you so much.
Thank you.